All right, this video will help with Chapter 5, Number 20. The problem says the cholesterol levels of an adult can be described by a normal model with a mean of 182 milligrams per deciliter and a standard deviation of 21. So again, because it says it's modeled by the normal model, we're going to start off with the normal curve. And so the first thing it wants you to do is it wants you to actually draw and label the normal model. All right, so let's start off by drawing a sketch of our normal curve, which I have below. And we're going to label the mean in the middle like we always do. So my mean is 182, so this middle score will be 182. And then I'm going to label out plus or minus 3 standard deviations. So the first one, I'm going to go to the right here. My standard deviation is 21. So 182 plus 21 is 203. I add 21 again, I get 224. I add 21 again, and I get 245. Going to the left here, if I take the mean and I subtract 1 standard deviation, so subtract 21, I get 161. I subtract 21 again, I get 140. And I subtract 21 again, I get 119. So this curve is showing my mean here is 182, and then I'm just basically adding 21 and subtracting 21 that several times to get the rest of my curve. All right, our first question is, what percent of adults do you expect to have cholesterol levels over 200 milligrams per deciliter? So if I'm doing this problem by hand, I draw my normal curve, and I have my axes down here labeled. I'm going to figure out where 200 milligrams is. So it's so slightly under 1 standard deviation, I'm just going to draw straight down, I'm going to draw straight down here to where 200 is, and I'm going to go over 200 milligrams per deciliter, so I'm going to shade the area underneath the curve, and this is what I'm finding. So I need to, again, convert my 200 to a z-score. So 200 minus my mean, which is 182, divided by my standard deviation, which is 21. That z-score is 0.857, which I'm going to round to the nearest hundredth, which is 0.86. So this is what you're looking up in the back of the book in the table. So the table, if you find 0.86 on your table, it should correspond to the area underneath the curve as 0.8051. Now remember, that 0.8051 represents the area to the left. So everything that is shaded here in the blue, that is the 0.8051. So in order to find my answer, I need to take 1 minus 0.8051, and I get 0.1949, which converts to 19.49%. So 19.49% of the adults will expect to have cholesterol levels over 200 milligrams per deciliter. All right, the next question asks you to find the percent of adults do you expect to have cholesterol levels between 150 and 160 milligrams per deciliter. So again, we're going to convert both of these values to z-scores. So I'm going to take the 150 one first. So 150 minus my mean, which is 182, divided by my standard deviation, which is 21. And that becomes negative 1.52. So negative 1.52, I'm going to just roughly draw down right here. This is negative 1.52. I looked that up in the table in the back of the book, and the table in the back of the book, it corresponds to 0.0643, I believe it is. And so the 0.0643 is the area to the left of this. So that's this area right here. That's the 0.0643. Then I'm going to convert the 160 to a z-score. So 160 minus my mean, 182, over 21. And that is negative 1.047. So I round that to negative 1.05 because the table is to the nearest hundredth. And I look that up in the table, and that table corresponds to 0.1469. So negative 1.05 is about right here. And so I'll shade this in green. This area to the left is 0.1469, so that's the green area. So to find my answer, what I have to do is I have to take 0.1469 and I'm going to subtract 0.0643. And so the area underneath my curve is 0.0826. So roughly 8.26% of the adults would expect to have cholesterol levels between 150 and 160 milligrams per deciliter. All right, the next question is to estimate the interquartile range of the cholesterol levels. So remember the interquartile range, the IQR. The IQR is equal to quartile 3 minus quartile 1. So I need to find the quartiles. So I'm going to find quartile 1 first. Quartile 1 is the data value that says 25% of the data is below quartile 1. So I need to figure out where that data value is. So I'm going to use my table first. So I look in the table, the Z table in the back of the book, and I try to find a number as close to I can as 0.25 in the body of my table. Well, when I look up in the body of my table, I can get to 0.2546, and that corresponds to a Z-score of negative 0.66. And so I have put negative 0.66 right here on my standard normal curve. Then I need to look up quartile 3. And quartile 3 represents 75% of the data is below quartile 3. So in my table again, in the body of my table, I look for a decimal that is close to 75%, and I find 0.7454 corresponds to a Z-score of 0.66. So I've put 0.66 here on my curve. Well, now what I need to do is I need to convert these two Z-scores to actual data values. So I'm using the formula data value minus the mean divided by the standard deviation equals my Z-score, and I'm going to work it backwards. So the first thing I have, I'll go over here, is I have negative 0.66 equals my data value, which is unknown, that's my X, minus my mean, and my mean is still 182, and then divided by my standard deviation. And I'm going to solve this equation, and when I solve this equation, I basically get 168.14, because if I multiply by 21 here, I get X minus 182 equals negative 13.86, and if I add 182 over here, I get 168.14, which I'm going to round to 168. So this is my quartile 1. Then I'm going to do the same thing for my quartile 3. So my quartile 3 is 0.66 equals X minus 182 over 21. And if I solve that equation, I end up getting 195.86, which I'll round to 196. That is my quartile 3. So then my IQR, we'll go up here. My IQR is quartile 3, which is 196, minus quartile 1, which is 168. So my IQR is 28 for my IQR. All right, the last question is to find above what value are the highest 15% of adults' cholesterol levels. So if I'm the highest 15%, that means in my normal curve that I want 15% of the data to be above, and then I want 85% of the data to be below. So here in the green shaded is going to be represent the 15%, and then here in the yellow shaded, that will represent the 85%. So I need to look this up in my table again. So I always look up the value to the left. So I need to look up and find a decimal that is close to 0.85. So if I look at my table, again in the bottom of my table, and get as close as I can to 0.85, the closest I can get is 0.8461. That z-score is equivalent to 1.02 on my table. And so what I need to do then is convert that to a data value. So again, I'll work my my z-score formula backwards. So z-score equals x minus the mean divided by the standard deviation. So my z-score here is going to be 1.02 equals x minus my mean, which again is 182, divided by my standard deviation, which is still 21. And if I solve this equation, I go ahead and I multiply by 21. So 21 times 1.02 gives me 21.42. And then I add 182 over, so I get 203.42 equals x. And it says to round to the nearest integer, so since I want the highest 15% adults, I really want to go over this, so I'm actually going to round this up to 204. So this value right here will actually represent 204. So it's slightly over one standard deviation because remember your mean is representing 182 right here.